Okay, so this is our second look at parent functions and their transformations. So we're going to take a slightly different slant at it and look at it in a slightly different light. So we said that, or we can express that any function generally with its transformations could be expressed as f of x equals a times x minus h quantity plus k. And so if we're dissecting what this means, the a value here is if a is greater than 1, it'll stretch vertically. If the absolute value of a is less than 1, it'll just shrink vertically. Also a vertical compression. Terms are interchangeable. And if a is equal to 1, then it will remain normal. So if a is a negative number, then it will reflect across the x-axis. Now the quantity x minus h, if it's x plus h, that means that h is a negative number and the graph is going to move left h units. If it's x minus h, then it's going to move to the right because h is a positive number. So then finally, k is our vertical shift, so basically we're going to shift up or down k units. So that's the general rule for function transformations. Now let's take a look at the function f of x. F of x is equal to negative x plus 4 quantity squared plus 3. And we want to write g of x, function g of x, in terms of f of x. Kind of like when we write y in terms of x. We're going to write g of x in terms of f of x. So the function f of x, we can say, is negative f x plus 4 plus 3. So where I'm getting that is from that, look at the previous slide. It's that whole f of x is equal to a, and so our a value here is in front of the x, and then x minus h. Okay, so we express that part, that's here, and then our plus k, which is right here. Okay, so we're just rewriting it in this very simplified fashion when we write it in terms of f of x. So our a value here in this case is negative 1, so that means it's a vertical reflection. And other than that, it's going to be normal. It's not going to be vertically compressed or shrunk or vertically stretched. And then our the x plus 4 in this case tells us that since it's plus 4, we're going to be shifting to the left 4. And then since we have a positive 3, that means we're going to shift up 3. So let's take a look at another one. So here we have a square root function. So again, it doesn't really matter what the function is. We're just looking at the transformations, and we're writing it in a simplified way. So for this one, we have f of x equals 2 square root of x plus 4, square root of the quantity x plus 4 minus 4. And so if I'm going to write g of x in terms of f of x, I'm going to write 2f and then x plus 4 minus 4. Okay, so then af x plus 4 minus 4. So since a is, so we'll look at it, a is 2, and then we'll have x, the quantity is going to be x plus 4, and then minus 4. Because a is 2, that's going to be a vertical stretch. That's the one that's going to be narrower. And other than that, it's not reflected. So there's going to be no reflection because it's positive. Because we have x plus 4, that's going to indicate to us that's going to be a shift to the left 4. And then minus 4 for the k means it's going to go down 4. Okay. So for this next one, I want you to pause the video and try this one on your own. In 3, 2, 1. Okay, take a look at that. So we have vertical compression or vertical shrink, no reflection, right 6, down 1. Okay, so now we're going to work it the other way. So we want to come up with an equation where that'll have an x-axis reflection, a vertical shrink by 1/4. We want it to shift right 2 and then shift down 1. So our a value to be reflected, or vertical reflection over the x-axis, means it's going to be negative. Since it's going to be a shrink or compression of 1/4, it's going to be negative 1/4. Since we're going to shift right 2, then that means it's going to be x minus 2. And then since we're going to shift down 1, that's just our k value is going to be negative 1. Okay, so let's put g of x in terms of f. And so we'll have negative 1/4 f in the quantity x minus 2. So again, it doesn't, and then we go down 1, so it doesn't really matter what the function is. It's the transformations are going to be the same. So I'm just going to make up a function, and let's say, okay, I want to do absolute value. So therefore, so f of x, so as I write it as a function, I could do absolute value, which would be 1/4 the absolute value. The absolute value of x minus 2 minus 1. Okay, or if I wanted to, it could have been a square root function. It could have been f of x equals negative 1/4 the square root of x minus 2 minus 1. Okay, so hopefully this gives you a little better feel for the transformations, how they work. So I want you to try one on your own. Try this one and then come up with a function of f of x. I don't care which parent function you use, so go ahead and give it a try. In 3, 2, 1. So here you go. Your a is 3. Your quantity is x plus 4, so your h value has to be a negative 4. And up 7 means your k is 7. And then you can pick any old parent function to fit that into. So for instance, if I wanted to do a quadratic, I could just do f of x equals 3x plus 4 quantity squared plus 7 would work just fine. Okay, so let's take a look at this, where we have a graph. Here we have function f, okay, and here we have function g. So we've got a couple tables here we can fill out. F, if we look at corresponding values here for negative 6 and 3, we can fill out what f of x is going to be. So when x is negative 6, y is 6, and then negative 3, 3, its vertex is at the origin, so it's going to be 0, 0, and this is symmetrical, so that will be your values of f. Now let's do this same thing for g of x. So if I look at the value of if I look at negative 6 for x, I can see that it's at 2. Okay, and then negative 3, we look here and oh, it's at negative 1. The vertex is at 0, negative 4, and then this is going to be symmetrical. One of the things that you might want to notice here is on the graph here we see everything is, or g is shifted down 4 spots from f. If you look at the y values here, they're all 4, or g is 4 smaller than f. So 6 minus 4 is 2, 3 minus 4 is negative 1, 0 minus 4 is negative 4. So we can kind of see how that shows up as a table. So how does g of x differ from the graph of f of x? Well, g of x is shifted down 4. So now let's write g of x in terms of f of x. So in this case, since it's just shifted down 4, this one's going to be fairly straightforward. It's simply going to be f of x minus 4. We don't have an h here, that's 0, and then our 1, we don't need to write that down. So that is g of x written in terms of f of x. So that concludes this portion of the tutorial.